I'm Annette Macias from Group 11, and in this section I'll be walking through the UML diagrams that guided our design and implementation of ECE373TheGame, along with our use cases and how we handle edge cases and exceptions throughout the system. Let's start with our use case diagram. Our system has one primary actor, the player, who interacts with 6 main use cases. First, start new game. This initializes a fresh game with 3 lives at level 1. If it's the player's first time, they'll see a how to play tutorial. Load game allows players to restore progress from any of 3 slave slots. We handle the exception where a slot is empty by displaying empty slot and preventing selection. Save current game preserves the current state, level, lives, and question progress to a selected slot. Erase old game lets players delete unwanted saves. The exception here is if they try to erase an already empty slot. We simply don't allow the action. Answer student questions is our core gameplay use case. Students ask ECE373 questions. The player selects an answer. Correct answers increase progress. Incorrect answers cost a life. Finally, leave game early returns to the main menu with an option to save first. Our activity diagram shows a complete game flow from start to finish. Starting at the main menu, players can branch to new game, load game, or erase game. The new game path shows first-time players receiving the tutorial, then entering core gameplay. During gameplay, players answer questions. Correct answers increase the progress bar. Wrong answers decrement hearts. Notice the decision points. If a heart reaches 0, we go to game over. If the progress bar fills, we check if there are more levels, advancing to the next level, or triggering the win condition. The pause menu allows saving mid-game. The diagram captures every path through our system, including the exception flows. Now let's look at our sequence diagrams, showing object interactions over time. For Start New Game, the player clicks the button Main Menu UI, calls Start New Game on Game Controller, which initializes the game state with level 1 and 3 lives. For first-time players, it triggers Show Tutorial before loading the classroom and starting the game loop. The Answer Student Question sequence diagram shows our core gameplay. When a student raises their hand, the player clicks them. Question Manager retrieves the question data and displays it. The player selects an answer, which goes to Answer Validator to check correctness. For a correct answer, we show a green check mark. Call Update Progress on Game State and check if the level is complete. If progress is under 100%, we continue. If progress is at 100%, we display Level Complete. For an incorrect answer, we show a red X, decrement the life counter, and check the wrong answer count. Here's our key exception handling. If this is the 3rd wrong answer and lives equal 0, we trigger Game Over, recording stats, setting the reason, and displaying the Game Over screen before returning to the main menu. Our state model defines 11 distinct states with specific transitions between them. Transition state table shown here. Looking at our overall state diagram, starting from main menu state, we can transition to instruction state for new players, load game state to restore progress, manage save state to erase files, or directly to active gameplay state. During active gameplay state, answering questions leads to answer validation state. From here, the transition depends on guard conditions. Correct answer with progress under 100%, this returns to gameplay. A correct answer at 100%, this goes to level complete state. Incorrect answer with lives remaining continues gameplay. An incorrect answer with 0 lives transitions to game over state. The pause state allows branching to save, resume, or exit, each with its own transition path. Here you see our state diagram with entry, do, and exits. Each state has defined entry actions, do activities, and exit actions. For example, our active gameplay state loads the level on entry, monitors students during the state, and updates progress on exit. Now onto our domain class diagrams, including our core mechanics, UML. In core mechanics, we have game entity as an abstract base class. Both player and student extend it, demonstrating inheritance and polymorphism. Player manages lives, score, progress, and streak. Level contains a list of questions, each holding answer objects. The controller package has Game Manager as the central coordinator with composition relationships to player, level, and save system. Save system manages save data, objects for persistence. The GUI package contains our 10 screen classes: Start, Game, Level, Pause, and so on, each responsible for its own display and user interaction. Finally, our exception handling ensures robust gameplay. Highlighting critical edge cases, we're starting with the save system. Here, invalid slot numbers are silently ignored. Corrupted files return null and default missing fields. Database connection failures are caught and logged without crashing. For gameplay, we check lives immediately after each answer. Reaching 0 triggers game over. Progress uses greater than or equal comparison to catch any overflow. The streak bonus at max lives grants a saturation heart instead. For levels, missing files throw expected null pointer exceptions caught by our tests. Questions with fewer than 4 answers simply hide unused buttons. And a noticeable logic edge case, an absent student calling raise hand, does nothing. Our guard condition prevents illogical states. The JUnit test raised hand when absent validates this behavior. These UML diagrams, use case, activity, sequence, state, and class diagrams provided the blueprint for our implementation, while comprehensive exception handling ensures the game remains stable under all conditions.
So I'm John, and my partners are Daryl and Manette. I'm going to take you through some of the initial gameplay here. So first, when we first start the game up, our initial pop-up screen shows up here. So you're given 3 options: play locally, play online, or quit. When you hit quit, it just deletes cuts the program, and then you can choose to play locally or play online. Play locally and play online, the game runs the same. The only difference is when you play online, it'll save the data to an online database so that it can be accessed on different computers when you enter in the username. Daryl will show you more about that later. I'm going to kind of show you the basic gameplay here in the play locally, where it saves the data to your computer. So when you first start into the game, you're given a few options. You can start a new game, load a save game, see how to play, erase, save, and quit. So first we'll just kind of click the how to play screen. Kind of just tells you how to play. Asking questions, wrong answers cost a life. Live 0 equals game over. You get a saturation heart if your streak gets up to 3, and I'll show more about that later. And then, you press save to store your progress. So then, every time you start a new game, the how to play screen is going to pop up. So if we click start a new game, how to play, and start game. So this is our kind of level area. So when you first enter a level, whether you load, come back from the pause menu, or start a new game, obviously, you're going to see this ready button come up. And once that ready button comes up, then your first question arrives. So what symbol do you put on a UML property that is protected? That will be the pound symbol. So it's correct. So your streak increases and your progress increases. We can vary this in our program. Typically, we'll do between 40 and 20%, depending on how fast you want to get through a game. And then so to kind of show how the streak works, which of the following is not a pillar of object-oriented programming? That will be compilation. And in a UML class diagram, what does a fill diamond represent? That represents a composition. So we completed level 1 because our progress bar hit 100, so it reset, and then our streak also hit 3, so we got that saturation heart. So now let's say we get one wrong. So which design patterns ensures a class has only one instance? That would be singleton pattern, so we'll get that wrong. And as you see, our streak reset, and that saturation heart went away. So what if we get another one wrong? What is the main purpose of abstraction object-oriented programming? That would be to hide implementation details and show only functionality, but we will click to connect 2 classes together to get that wrong. So that's how you lose a heart. And then we're just going to get the next 2 wrong to show the game over screen. So in a state diagram, what does a transition represent? That would be this one, but we'll just do a data type. And then what is coupling in software? Coupling is not a type of inheritance. So we'll get that one wrong, and then our game over screen pops up. And it tells you what level you made it to, and game over. And then since the game's over, obviously you're not allowed to save, so you only option is to go back to main menu. Alright, so now I'm going to show you kind of the load game and erase game features, and then the win screen. So first I'm going to show you how to erase a save, because we have a few on here already. So it shows you all of your slots, and then you basically just select one to erase the game. So we're going to erase this top one right up here, empty slot. So then, it's erased. so you have another slot. But you can overwrite slots also when you save a game. We'll go back to the main menu, and now we're going to load into a game and show the win screen. So let's go slot 1, level 10. Level 10 is the max level right now. So we'll get these 3 questions right, and then hopefully we can just win the game. So what is the chain of responsibility pattern? That's the passes request along the chain and handlers until one handles it. That's correct. What is the difference between aggregation and composition in UML? There is a difference. In composition, the part cannot exist without the whole, whereas aggregation it can. That is true. And then what is the visitor pattern? It separates an algorithm from the object structure on which it operates. That is true. So level 10 complete. And there's our win screen. It kind of shows up over the whole thing. You got our amazing professors. And yeah, and then you can go back to the main menu. And so now I'm going to show you how to save a new game. I'm going to show you saving and loading the new game. So start the new game. So let's just get a couple of these correct, and then we'll also get a couple wrong. So then we're down to 1 life, and we're on level 1. So what we're going to do is we go to our pause menu, where you can either go back to game, save game, or main menu. Just to show you, whenever you go back to a game, we kind of want to, in a way, penalize somebody for not making it to the end of a level, or basically not making it to the end of the level either before they pause or like go back to the main menu. So what happens is it resets your progress in that level. So in this case, if you go back to game, it still gets rid of your hearts, but it takes you back to level 1. So like if we get our 3 right here, let's see, then it takes us to level 2, and we also got our heart back for our streak going up, and then it reset our streak. So now let's get 1 right again. So then let's go here. Since we did the back game, let's now save the game. We'll save it into this empty slot. And just to show you also, you can overwrite saves if you really want to. So we'll overwrite this one right here. So you can overwrite as many saves as you want. If you want all of them, like say you want in multiple instances for some reason, like you don't want someone deleting all your data, you can do that. And then in this case, we'll just go back to the main menu. We'll just erase a couple games. And then again, I already showed this by going to level 10 one, but load the game. Starts you at 0, but it does keep your streak this time. So yeah, cool. And then one last thing for me to show you is if you're trying to load a game and say you're trying to load an empty slot, it doesn't let you, nothing happens. You either gotta wait or go back to the main menu. And everything you have is basically, there's always kind of a go back to main menu, it'll save there, and then click quit here also. Okay, and then also when you go to play online, it asks you for a username. So if you don't ever put in a username, basically it's like, oh, maybe you won't split up, so wait here. So you play online, you have a couple of usernames, admin in this case. So when you log in, basically it logs you into like your accounts on the database, so it has your saves to that username. So now if we go to load game here, it takes a second because it's connecting, but you can see admin has its own slots here. And to show you that different usernames have different saves, we'll go back and now we'll run play online. The username John. And if you don't have a username, it automatically creates it and just puts your saves as like null, like empty slots. So now if we go here and load game through John, you see it's different.
Hi, my name is Daryl Mercado. I'll be going over ECE373TheGame and how we are able to set up the game. So given the zip file, you're going to insert the zip file, extract it, and you're going to create a hierarchy structure similar to this. So you're going to have our source folder, and we're going to have packages of controller, core mechanics, data, game drivers, GUI, images, tests, and we're going to construct them with the following files. You may pause the video in order to follow along with these files, and you're just going to import them in directly. There should be no changes in the files when you import them in. The only special exception to setting up the file is going to be our jar file that was included in order for us to have online capability. Our project is not going to be able to build if this jar is not included into the file, and I'm going to show you how to do so right now. So you're going to right-click the project folder, and you're going to go to our build path. You're going to look at the drop-downs, and you're going to configure the build path, and that should open up this pop-up saying Java build path. We're going to go to the libraries tab, and we're going to be looking at our class path. And because I already imported it into the project here, it's already present, but I'm going to remove it, and it should look like this when you first enter the project. Clicking on class path, we are now able to select from these dropdowns, and we're going to add an external jar file. And we're going to select this file right here. And this should be included inside of the zip file, and we should be able to find it. Right now I have it stored inside of my downloads, and we're going to press apply and close, not cancel. By applying that, we should now be able to see reference libraries, and they will be appearing at the bottom. This will allow our project to be able to compile. Now I'm going to be going over our code. I'll now be talking about primary classes inside of our program and particular functions that are unique about them. So in Game Manager is acting as our central hub and allows for a singleton style approach, and that's where we initialize player, level, and save system. The most crucial part about this class is our run level program method. So this gives us our primary game loop, and it checks if a player is alive, it monitors the progress bar, and acts as a bridge between the user input and the game logic. It pulls a question, selects a random student to ask it, and it waits for a response. And then when the user submits an answer, the process answer method takes over, and the logic is able to be supported, where if the answer is correct, it updates the progress bar, manages the streak mechanic, and if the player gets it right, they gain progress, and if they're wrong, they lose a life. It also triggers the game over sequence and advanced level sequence based off of the results of the question and the amount of status that the player is at. Next, I'll be talking about our save system. Our save system is using a hybrid style and robust approach where we can either choose between storing things locally or on the cloud. This was something that we added as a very much a quality of life, and also we wanted to test the information that we learned from the class and apply it to learn in a more dynamic way. This was beyond the scope of the class, especially when it was something related to a cloud, but the information of how to write things into a file directly impacted the ability for us to understand how this worked. So we utilized something called Supabase, which is a online web development tool that has a cloud-based storage system, and this allows us to store player saves, and it stores it in username, slot, level, lives, saved, and we created this table based off of a SQL editor, and then based on this table and a username, it's able to retrieve information related to the gameplay that the current player had. So we utilize a communication protocol, JDBC, and this is the URL that we're using. It's posting, and then it's passing with a password. And this was similar to posting and getting, and we learned this inside of a Internet of Things class. This essentially prepares a statement to send into the database, and the database is deconstructing that statement that was sent one time, and then when we load, the database is sending us information, and then we're deconstructing it here, and then we're using try and catch statements so that if something goes wrong, we're able to dissect at what point of failure did that happen and actively know the status of our environment. It's also important for us to talk about the level and questions. So inside the level class, we're essentially looking at a numbered text file, and from that text file we're able to parse information such as the question, the answer, the feedback, and if it was correct or not. So this is what our text files for our levels do look like, and it stores the question. We have a level up to 10 levels that we created, and all of these questions were created by Manette, and these questions are unique and very native to the class. And our GUI is essentially an extension of all of our core mechanics and controller elements, but instead adding a window, and each window would create a new window to the next GUI element based off of the state transition that the player is requesting. I'd like to cover over our JUnit test cases that we created and showing that each of the elements that we did use worked. And this was essentially a sanity check to make sure that when we would incorporate a larger class, each of the components would work correctly. This utilized isolation, so each function is going to be working independently from one another so that when they do become dependent of each other, we can understand where that point of failure was. Our JUnit test cases are essentially just looking over the functions of our code and testing each function separately. That consists of our JUnit test cases, and we also have our game tester here, which is a console level in our sandbox, and this gives us direct feedback of what's going on. If I log on to admin, just how I talked about the database working, if we choose load game, we can see that when it retrieves it, it's all the information stored on that database. Thank you.
Thanks for watching. This is the end of our presentation of our ECE373 final project.